Welcome to another futures video. And I just want to back up and just mention in the last video, we saw this relationship that basis is equal to cash price minus futures price. And we saw that with a cash and carry quasi-arbitrage, that whenever the futures price got too high relative to the spot price, that the arbitrageurs would undertake the cash and carry quasi-arbitrage trades and thereby keep the futures price from going too high. And we saw last time that if you make the futures price unable to go too high, that it keeps the basis from going too low. So we can say that cash and carry quasi-arbitrage activity effectively puts a lower bound on the basis. It puts a lower bound on the basis. Puts a lower bound on the basis. And that's important, okay? That's a very important thing. Excuse me. Let's now look at a different circumstance. New circumstance. The current spot price of silver bullion is assumed to be $17. Everything is per ounce. Okay. The silver bullion futures contract is $17.10 per ounce, and the carrying cost per unit through the delivery date of this silver bullion futures contract, although we don't know it for sure, we know approximately when it's going to be, 20 cents. Okay, so what will we do? Well, let's see. We can ask ourselves, does the full carry model, as stated, become satisfied or be consistent with equilibrium with these values? Well, so that's the futures price is equal to cash price plus carrying cost per unit, 17.10. Does that equal $17 plus 20 cents? And the answer is no. In fact, 17.10 is less than 17.20. Oh, okay. So the full carry model equation is not satisfied with these values. And these two are indeed market prices, and we can trade on those market prices. And what will we do? Well, we're going to see that now we're going to do something called a reverse cash and carry quasi-arbitrage. Okay? And so what are the trades that we're going to do? Well, at date 0, we are going to, it appears that the futures price is lower than it should be. If we're trusting our quants that number at 20 cents is correct, then it appears that the 17.10 is too low. Well, the implication then is in relative terms, the spot price is too high. So what do we do in arbitrage? Well, we're doing something in the spot asset, and we're doing something with the futures contract. Futures arbitrage, this is. And so we're going to buy the underpriced and sell the overpriced. So what's overpriced is the spot asset. So we're going to go short 1 ounce spot silver. And then what's the cash flow associated with doing that? Well, spot silver is $17. So we're going to receive $17. $17 coming into us. And of course, we do the opposite with the silver bullion futures contract. We go long 1 silver bullion futures contract, and there's no cash flow associated with that. That's just locking in a price of $17.10 at some time in the future. Okay, the delivery would, coming up maybe next month. That's specified in the contract. And then we're going to invest $17 in a risk-free asset. Okay, so there's minus 17. So when we do this, there's no cash outlay right now. We got $17 invested. Well, what happens at date 1? When all's said and done, what happens at date 1? See how the arbitrage works. Well, we owe 1 ounce of spot silver. And fortunately, we own 1 ounce of silver. So at date 1, per our futures contract obligation, okay, we have got, we must take delivery of 1 ounce of silver bullion, right? And what's the cash flow associated with that at date 1? Well, the price we locked in was $17.10. Right? It's the price we locked in because we went long it. And so we are going to then have to pay $17.10. And then what else happens now? Well, see this investment we have here? The Treasury security we bought? We paid $17 for that. And the idea is it's going to mature. So we're just going to say that our Treasury bill matures, and we've got a cash inflow. And now, we knew the maturity value of our Treasury bill when we put this quasi-arbitrage trade on. And so in order for this to be profitable, we must have had a sufficient maturity value to enable this to be a go. So let's just pretend it was $17.15 was the maturity value. And there you can see that the cash flow here at date 1 will be a net cash flow of 5 cents per ounce. Oh, okay, very good. And so we can profit here. And again, we had to know this maturity value in order to decide and choose to undertake this series of trades. Otherwise, we could make a bad mistake. Okay, so that's crucial. Now, so what happened here? Well, we thought the futures price was too high. We thought the futures price was too low. We thought the spot asset price was too high, speaking in relative terms. And it's interesting because the futures price was still higher than was the spot price. It just wasn't higher by enough to satisfy the full carry model. Okay, there and then with the numbers right there. Okay, well, how many of these trades will we do? Well, we'll do as many as we can, but we're not going to be able to do an infinite amount of these trades because what we're doing in order to capture the arbitrage profit is actually pushing prices back toward an equilibrium because we are in this position, we're shorting the spot silver and we're buying the silver bullion futures contract. And so we're driving down the spot price. So the spot price is being driven down while the silver bullion futures contract price is being bid up. And let's just see where this profitability, might end. Well, it ends whenever the difference between the cash price and the futures price is equal to carrying costs per unit. So the spot price could drop, the silver bullion futures contract price could rise, and at some point an equilibrium occurs, and one such equilibrium could be 16.95 per ounce and 17.15 per ounce. Why is that an equilibrium? Well, because the difference here is 20 cents. And that 20-cent difference between the price of the spot asset and the futures contract price is equal to the carrying costs per unit. Okay? And so that's where the arbitrage profit disappears. So here, if we could always execute these reverse cash and carry quasi-arbitrage trades, if we could always execute these trades when we wanted to, okay, then what it would do is it would keep the futures price from getting too low. It would keep the futures price from getting too low. Well, let's look at our formula for the basis. Basis equals cash price minus futures price. Okay, if we're going to engage in a series of trades that keep the futures price from getting too low, that's interesting. If we stop this price from getting too low, what we're doing then is we're keeping the basis from getting too high. Okay? So what we'll do, if we could execute these reverse cash and carry trades all the time, we're going to find out that there's a reason why we may not be able to do that in a little bit. But if we could do them all the time, unimpeded, then the reverse cash and carry quasi-arbitrage trades would put a lower bound on the futures price, and therefore it would put an upper bound on the basis. Okay, interesting. So this is a reverse cash and carry quasi-arbitrage, and it is an important thing to understand, and that's an example to help you understand that. So now, I think that's enough for this video. Thanks for watching.